All right, 2019 semester 1 exam review. What you might want to do, you might want to just pause the screen right now and go through and look at your answers. And then that way you don't have to watch the entire video. You can only watch the ones that you missed. You'll notice that there's about 10 or 12 free response mixed in with the multiple choice. So like I say, pause the screen, check your answers, and then we're going to go ahead and we're going to get rolling. So let's go all the way back up to the top. Get a little bit better view for us here. And back to number 1. All right, here we go. So we're trying to find the missing piece right here. The big thing that we need to understand is that when you have line segments like this, the distance from C to D plus the distance from D to E equals C to E, the whole thing. So basically, if we call this X, we could set up an equation that says X plus 5 equals the whole distance. So it's just a subtraction problem. Take away 5 from each side, and we get X equals 9. Correct answer is B. Number 2, find J to H. So our ultimate goal is find all the way from J to H. I'm going to put a little dot here just to make it look normal. So it looks like we're going to need to add 4 plus this amount over here. So we're kind of missing this IH piece. So let's see if we can use some of the blue pieces to help us out. Well, the first thing I notice is I notice this 11 right here. So 11 take away 4 tells me that that piece is 7. And now I can use the whole 16. So I know that 7 plus 4 is 11 plus 5 more will give me to 16. So now it's not too bad. To find out how far it is from J to H, I can simply add these two together for an answer of 9. All right, so let's check out 3 and 4. Similar idea with number 3, except for now we have some algebra to set up. So I'm going to say GH plus HI, so GH plus HI equals G to I, the whole thing. So let's do this. We have the left added to the right equals 11. And combining like terms, I have 1x plus 2x, that's 3x. I have a minus 1 and a minus 6, so that's a minus 7, equals 11. And I'm going to add 7 to both sides, and I get 3x equals 18, divide, and we get an answer of x equals 6. We may want to plug it in just to see. So 6 take away 1 is 5. 2 times 6 is 12 minus 6 is 6. And that checks out. 5 plus 6 does come out to be 11, so we're looking pretty good. All right, number 4, we're moving into some parallel lines here. So these little arrows here, remember, tell me that these two lines are parallel, which we create this Z thing going on right here, which gives me some alternate interior angles that must be equal. So I'm going to set up an equation where x plus 53 equals 50. I minus 53 from both sides, and I get an answer of x equals negative 3. Now remember on these problems, whenever you have the situation with parallel lines, this angle and this angle need to match, this angle and this angle need to match. So those are all like vertical angles. Right here you have the same ones on the top, same ones on the bottom, and then the other ones all should match as well. So you should have all the greens matching up as well. So you should only really have 2 different values when you have parallel lines. 8 angles, only 2 unique values. All right, number 5 and number 6. Number 5, so we have a right triangle. We do know that all triangles add up to 180 degrees. Since this one's 90, the other two have to add up to 90. So a couple different ways I could do this. 90 plus 50 gives me 140. And 140 subtracted from 180 tells me that this angle right here is supposed to be 40 degrees. So I set up an equation and I say 5x equals 40 degrees. Divide both sides. And it looks like x is going to equal 8 on this one. Number 6, this one involves the exterior angle theorem. So we have a formula. Anytime you have a triangle and you extend one of the sides, you have this exterior angle. And if you look at the angles inside of a triangle. Let's just call this x and let's call this y. There's a theorem that always works that the exterior angle should always equal the remote interior angles, or the two far away ones. So whatever this outside angle is, it needs to add the other, it needs to equal the other two added together. So we have the exterior angle needs to equal these two added together, which I'm going to combine like terms right now. I'm going to add the 66 and the 3 to get 3x plus 69. Save a step there. So now I have to solve an equation with x's on both sides. I always attack variable first, and I attack the smaller one. Just makes life a little easier for me. So I subtract 3x from both sides. I get 7x plus 6 equals 69. Take away 6 from both sides. It's going to give me 7x equals 63. Divide both sides by 7. 63. Just kind of erase that, make it look a little bit better. So 63 divided by 7 gives me x equals 9. Man, we seem to get a lot of answers so far in this test that x equals 9. All right, let's keep on going. Number 7 and number 8, these involve the angle addition postulate. So this was back in chapter 1, angle addition postulate. And basically what this postulate says in general is that whenever you have a ray on the interior of an angle, you basically split the big angle up into two pieces. So we have angle 1, we have angle 2, and then we have the entire angle called angle 3. And it basically just says that we can add those angles up. 1 plus 2 equals 3. Technically, I should have little m's in front of them to show the measure of, but you get the point. So sometimes you need to subtract, sometimes you need to add. So let's label this first. So the measure of FTU, so FTU, so that's this angle right here, is 49. And then the measure of STF, so from S to T to F, that's this angle right here, that's 31. And we want to know, what is angle STU? STU is the whole thing. So we have the two small pieces. We add them together. 31 and 49 gives me 80 degrees for the entire angle. Correct answer C. All right, number 8, we label QRS as 124. So Q to R to S is the entire angle. It's all of this. So the whole angle is 124 degrees, the big dog. And we have QRF, which is 84. QRF is this top angle. And we are missing the bottom one here. We're missing, find the measure of angle FRS. So we're missing that one. So we could call it x if we'd like and set up an equation. Don't really need to, but x plus 84 should equal 124. Or you could just subtract 84 from 124, and you will find out that FRS is 40 degrees. All right, let's jump into number 9 and 10. Looks like similar idea, but cranking it up a notch with a little bit of algebra. So we have LMH. LMH is 4x minus 5. That's this little fella. And then HMN. HMN is here on the left. That's 9x plus 11. And then we know the big dog, LMN. So all of these two added together, almost a full circle, but not quite, is 162. So our equation needs to set up. We need to say that little plus little equals big. So let's get after it. We have little plus little equals big. Now don't get all happy and start doing things to both sides. We want to combine like terms. So I need to combine my x's and get 13 x's. Then I'm going to combine my constants, or my numbers. Positive 11, negative 5, that's positive 6, is 162. Now I can start doing things to both sides to isolate x. Minus 6 minus 6. I got 13x equals 156. divide both sides by 13, and we're looking at, what's that going there? 1, 2. So x equals 12. What do they want? Find x. Good. Be careful though. Sometimes you got to plug 12 back in to get the final answer. So I always go back and see what we're after. Correct answer there is C. All right, number 10. Similar question. R cubed P is 142. So R to Q to P is this whole big dog here, 142. So setting up an equation, I know that's going to be the one over by itself. And now the smaller pieces, let's see, SQP is 15x, so that's this bigger piece. So 15x. And then I'm going to need to add to that this little fella, RQS, which is x plus 14. Can barely get him in there. So I got to add x plus 14. And now we just take off. Again, combine like terms. There's a 1x here, so that makes 16 x's. Added to 14 is 142. Subtract the 14 from both sides. 16x is, what's that, 128, I believe. 16 goes into 128. Looks like 8. And then again, I can plug it back in, see if it works. But I'm going to trust myself on this one. All right, moving forward. Number 11 and 12. These are naming. These shouldn't be too bad at all. We can fly here. So two angles. They don't add up to anything special, but they are next door neighbors. All right. So the big idea here is that they share this common side. They have a common wall with each other, but they don't add up or they're not equal. There's nothing special. So we just call those guys adjacent. Number 12, these two, they are adjacent. You know, they do share this side, but when you put them together, B plus A would have to equal 180 degrees because they form a line. So this is the answer, line pair, linear pair. They're also supplementary. Supplementary is something that means you're equal 180, but you're not necessarily a line pair. All right? All linear pairs are supplementary, but not all supplementary angles are line pairs because they don't always share a side. All right, 13, 14. So whenever you see an x like this, so I have this x going on, opposite angles or kitty corner angles like this, they form an x. Those are called vertical angles. They're always equal to each other. That'll come up later on. This one, I see the little red box in here, which tells me that A plus B has to equal 90 degrees. And two angles that equal 90 degrees are complementary. So supplementary is 180, complementary is 90. All right, moving right along. We're going to use that fact here on number 15. A couple facts, actually. So I see a 90-degree angle here. And I see that this forms a straight line. All right, so straight lines are always 180. So that means that this side also has to equal 90. Now, it doesn't mean they're equal to each other. Well, then it wouldn't equal 90. But I know that this plus this has got to be equal to 90 degrees. So we set up an equation. 3x plus 1 added to 56 has to equal 90. Combine some like terms. 3x plus 57 is 90. Minus 57 from both sides. And I get 33. 33. And divide both sides by 3. And we get x equals 11. And that's what we want. Find the value of x. Question's over. All right, number 16. 16. The only angles that are important are this angle, this big obtuse angle, and then this little acute angle. Now, they're definitely not equal to each other. One's obtuse, one's acute. But they do form a straight line. They also form a semicircle, half a circle. So it's 180 degrees. So let's add these two up. 4 plus 5x added to x plus 14 equals 180. We're going to combine some like terms here. 5x's plus one more x is 6x. We have a positive 4 and a positive 14 giving me 18 is 180. And I subtract 18 from both sides. And I get 6x equals 162. Divide both sides by 6. And that goes in there 27, I believe. So I think x is 27. Correct answer there is A. Okay, number 17. Now we're getting into the midpoint distance type stuff. So formula for midpoint, there's a couple different ways to look at it. I always think is you average the x coordinates and then you average the y coordinates. So, thinking about this coordinate here, that one lives at a -2, -3. Okay, so remember, this is the x coordinate. We went left 2, down 3. And then this other point over here is at right 5, down 5. So our second point is at right 5, down 5. Well, all we're going to do to average the x coordinates are you add them up and you divide by 2. So let's just kind of focus on these guys right here. We're going to add them up and we're going to divide it by 2. So -2 plus 5, that's 3 divided by 2, which is 1.5. When we do the y's, we add up the y values. We get a -3 plus a -5 divided by 2, which is -8 divided by 2, which is -4. So it looks like our correct answer here is A. Now, if it's a multiple choice question, you may be able to eyeball it and kind of pick the right answer. So let's just verify. Over 1.5, down 4. Yeah, it looks pretty good. I like that one. Looks good. Number 18, find the distance between the pair of points. So I know there's a distance formula. We haven't really used that a whole lot. I like to use the Pythagorean Theorem, which is leg squared plus leg squared equals the hypotenuse squared. We've done this many times. In general, people say a squared plus b squared equals c squared. I just like to name it with legs and hypotenuse. So what we're trying to find here is the hypotenuse. This is the slanted side right here that we're trying to find. We can't count blocks because they're going on an angle. So what I need to do is I need to kind of do my own legs. So I'm going to draw the horizontal component. I'm going to draw the vertical component. And I'm going to give myself a right triangle here. So now I have a leg, and I have a leg, and I'm trying to find the hypotenuse. So let's kind of count these sides. So it looks like I have 3 units on this side. And then over here, I have 1, 2, 3, 4, 5, 6, 7 over there. So leg squared plus leg squared equals, I don't know, squared. If you want, you just take the square root of both sides. Take the square root, take the square root. So that is the square root of 9 plus 49, or the square root of 58. And I would accept that, or I would accept an answer of, let me just check that out. I know it's 7 7s 49, 8 and 8 64. So somewhere in the high 7s. Let's just punch it in and check it. Square root of 58. About 7.6. So 7.6 units for number 18. And it said to go to the nearest tenth, so that's why I only went 1 decimal place. All right, number 19 and number 20. So find the other end point of the line segment with an endpoint and a midpoint. So you could use graph paper on this one. I'm just going to kind of sketch a little nasty graph here real quick. And so I'm going to go 1, 2, 3, 4, 5, up 2. So that's an end point. So right 5, up 2. So there's an end. And then we have a middle at 0, 4. So 0, 4 is right up here. And that's the mid. So, basically what I need to do is, this line is going to go here, and it's going to keep on going somewhere up over in here. So that's where my point's going to be. Just looking at my choices, I know it's going to have a negative x value and a positive y value. The only option right now is B. But let's say this was a free response question. One way you could do it is kind of stair-stepping the slope. So I notice like on this one, if I stair-step the slope, we went 5 to the left, 2 up. So then if I went another 5 to the left, that would put me at -5. And then another 2 up would, let me see, I was at 4, 5, looks like I'll be at 6. So -5, 6. So I just kind of like to stair step the slope to find the other endpoint. It's one way you could do it. All right, number 20, identify the pair of angles. So looking at these angles here, and I have a big one right here, and I have another one right here. So those are called alternate interior. So remember, whenever you have a set of lines like this, and they didn't label these as parallel, it really doesn't matter naming-wise, but let's just say they were. Those two angles are called alternate interior. Alternate interior. Interior because they're both inside the parallel lines. Alternate because they're on opposite sides of this transversal. A line cutting across two lines like that is called a transversal. All right, keep on going. 21 and 22. So now I do have the parallel markings on there. And this angle has to be equal to this one because they're vertical. And then I can come corresponding angles down here. These two have to match as well. So the correct answer is D. Number 22, again, blue's got to match blue. It's got to match blue, got to match blue. So I know right now the answer is 87 degrees. If you wanted the name, these are alternate interior angles again. Keep on going. 23. You know, and I always just kind of do the same thing. Blue, blue, and then copy, paste, blue, blue. Oh, it looks like it's going to be 57. Now, if you wanted the fancy name, these are alternate exterior because they're on the outsides of the parallel lines, not on the insides. 24, this one's a little bit different because when I color code it and I say, okay, blue, 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 you'll notice that 53 is a blue angle, but the question mark is not. The question mark is the red. All right? So the question mark is something different. So the relationship is they have to add up to 180 degrees. So I need to go 180, subtract 53, and that's going to give me 127, D. And these guys are called consecutive interior, or I think we use the terminology same side interior. Either one will hook you up. Right, 25 and 26. 25, what you need for this one is you need to know the Triangle Sum Theorem, which basically just says, hey, all triangles add up to 180 degrees. So let's see what we have. Right now, when I add them up, I have 61 plus 64 is 125. And then we need to subtract 180 minus 125. And we will get 55 degrees left. So I think that'll make it work out. Correct answer, D. All right, number 26, couple different ways you could do this. If you want the fastest way, you can use the exterior angle theorem that we did earlier in this test. It might have been like number 6 or number 7. I know it was kind of early on. But this outside angle has to equal these two added together. So I could just go 70 plus 46 and get 116. Put those in there. But if you didn't know that, let's just say you forgot it. Okay, you could take a couple extra steps and you could figure out how much this angle right here is. All right, so we had 70 plus 46 was 116. Then you could subtract from 180 and get, what would that be, 64, all right, which is this side. And then since these two make a straight line right there, you could do 180, take away 64, and we should get that answer. We should get 116. So that's why it's kind of redundant. It's easier to use the exterior angle theorem because you kind of chase your tail around in a circle. But either way, as long as you get it right, you're good to go. All right, 27. This is one of these kind of long solvey type problems. So we need to kind of figure this thing out. So basically, if this is 90, this is 90. 90 plus 50 is 140. Subtract that from 180, which is 40 degrees. So now I have that. Now I need to understand that these people all make 180. So I have 107 subtracted from 180, which is 73. And the 45 can vertical angle in. So in this triangle here, right now I have 45 and I have 73 for a grand total of 118. Subtract that from 180, and it looks like final answer is 62 degrees there at the end. All right, 28. Moving into chapter 3, moving into some slope things going on here. So first thing I need to understand, especially if it's multiple choice, if you're going up from left to right, you have a positive slope. If you're going down from left to right, it's a negative slope. If you're flat, it's 0. And if you're straight up and down, it's undefined, or you have no slope. So those are kind of like your little cheat sheet. So just looking at this one, I know that it's going to be a negative, all right, because it's going down from left to right. And now, basically, we need to, slope is always, there's a couple different ways to look at it. Some people say rise over run. That's fine. Some people subtract the y's and then subtract the x's. This would be a good way if you were a programmer and you wanted to program the coordinates. I like to call it the change in y over the change in x, any of those. But basically, it's a vertical change over the horizontal change. So vertical over horizontal. So our vertical change is 1, 2, 3, 4. That goes on top. Our horizontal change, or our run, is 3. We knew it was negative from the start before we even started counting. So the slope of this line is negative 4/3. All right, number 29 and number 30. So when you don't have the picture, you could graph it, but it might be easier to just do the slope formula. Two ways you can do it. If you'd like to stack this up, you could use what's called the slope slide. So if I stack this thing up, you know, I have my x's over here, I have my y's over there. You can just do the slope slide. Just kind of come down, hook to the right. And now I'm going to subtract my two y values. So I'm going to go -4, take away -2. And then I got to do my x values. I got to do 18, take away 10. 18, take away 10. And let's clean this up. Minus a negative is really plus a positive. And 18 minus 10 is 8. And so that's going to shake out when I reduce it to a -1/4. So that's the slope slide. Some people, I like to do it this way. I just kind of go y minus y. -2, take away -4. And then x minus x. And you should get the same thing. The negative's in a little different spot. So this is 2 on top. This is a -8 on the bottom, which when you pull the negative out front and you reduce, you get the same answer either way. A slower method would be to graph those points and count the boxes. I'm not going to show that, but you could do it. Let's go over here. Find the slope of a line perpendicular to the given line. All right, so I look at number 30, and the key thing about perpendicular is we need to have slopes that are opposite reciprocals. Okay, so opposite means you're going to have one positive, one negative, and reciprocals means we're going to flip the fraction. So the first thing we need to understand about this one is it's in slope-intercept form. It's in y equals mx plus b form. And when you want to know slope, it's the m. It's whatever's in front of x. So the slope for this problem is a -1/2. Now, if I want to be perpendicular to this, I need to be opposite. I need to be positive. And then I need to be the flip of that, 2/1, which is just equal to +2. All right, 31 and 32. So now we're getting into graphing some equations. Y equals mx plus b. So some key features, you know, whenever you have y equals mx plus b, the m is the slope and the b is the y-intercept. So that kind of tells me where it crosses. So looking at this one here, I see the first key feature is b's got to be -2. So let me go through the answers. Well, unfortunately, that doesn't really help me because all of them have a -2. Sometimes you can eliminate a couple. The next thing I want to look at is I want to look at the slope. So I want to look at my m, and just looking at this line, it's positive. So I know m's got to be positive. So let's go through and let's eliminate. Well, this is a -1/2. That's a -5. Now I have two positive ones over here, so now we actually got to count the numbers. So remember, I'm trying to get from a lattice point, a corner, to the next corner. And it's vertical change over horizontal change. So vertical change over horizontal change. So I know my slope is 1/2. So the correct answer here is going to be B. Number 32, write the slope-intercept form of the equation of a line. It looks like I need to shrink this problem a little bit because it's going off the grid for me. And maybe I'll just go to a full screen for number 33, or 32 I should say. It's a longer problem. So, standard form is always written in what they call ax plus by equals c. And I need to get it into slope-intercept form. So the key feature is I need to get y equals. I need to get y by itself. So first step of getting y by itself is minus that 3x from both sides. That's going to leave me with 2y equals -3x minus 4. And then I'm going to divide everything by 2. And I'm going to get -3/2 x minus 2 when I divide that out. So the correct answer here is B. All right, let's go to 33, see if we can get back to a couple per page. Might be a little bit faster. Well, I'll have to change it when we get to 34. All right, so another one, write slope-intercept form. So number 33, it looks like I have a slope. So this is my m. My m is -4/5. Well, that right there, the problem's over. The only one that has an m of -4/5 is right there. Also, it has a y-intercept of +2 at the back. So we're good to go. All right, number 34. Let's check him out. Write the equation of a line that goes through -2, 1 and is parallel to this fellow. Well, unlike perpendicular, parallel is nice because we get to use the same slope. So whenever I want to write the equation of a line, there's two steps. Okay? Step number 1 is I need to have a slope. And step number 2 is I need to have some point. I need to have some point that it goes through. If I can get the slope and I can get a point, we're really good to go. So let me see, this line that we're talking about here, his slope is 3/2. So my line's got to have a slope of 3/2. So let's just get my starter equation going. Y equals 3/2 x. And what I don't know is I don't know the y-intercept. So I'm just going to write in plus b. But what's really nice is I have a point that I can plug x and y in for. So remember, this is my x, this is my y. They're saying I got to go through this point. So let's plug this in for x. And let's plug this in for y. And I get 1 equals 3/2 times x added to b. And you could use your calculator if you know how to do it by hand here, but I got 1 equals, that's going to be a -3 added to b. You know, it might help you guys to put a 1 under it and just multiply 3 times -2, which would be -6. You know, 3 times -2, and then 2 times 1, Then you just divide those, you get negative 3. But then I'll get b because then I can add 3 to both sides. So I shouldn't have wrote it like that. So then I'm going to get b equals positive 4. So b equals 4. So now I know what to replace in here. So let's write the final answer. Y equals 3/2 x. Instead of plus b, I now can say, hey, I know what b is. It's positive 4. And bam, we're good to go. Correct answer here is A. All right, let's jump into number 35. Oh man, unfortunately 35 is a long one too. So same idea. We need a right equation of a line that goes through -5, -3. So there's my x and y. I got to be perpendicular on this one. So since this one, the slope is 5, I need to make 2 changes. I got to be opposite. So since this slope is really positive 5/1, my 2 changes are I need to be negative and I need to be 1/5. All right. So my new slope's got to be -1/5. So let's kind of write this over here. Step 1, get the slope. Got it. -1/5. Step 2, use my point where x is -5, y is -3. Let's plug that joker in and let's solve for b. So starter equation. Y equals mx plus b. Grab these points here. Slap a -5 in there. Slap a -3 in there. -3 equals -1/5 times -5 plus b. Then I get -3 equals a negative times a negative is positive, and those are reciprocal, so it just comes out to be 1 plus b. Subtract that 1 from both sides. Looks like in this case b is -4. So I got my b, I got my slope. We should be ready to kick some butt. Write this in here. Y equals mx, and there's my b. Correct answer, bam, D. All right. So number 36, see if we can go back to 2 at a time. These are going to go pretty fast because they're just classifying. So you classify by angles and sides. Look at the angles first. So I have less than 90, less than 90, less than 90. That means it's acute, and there's only one acute, so I know I'm kind of done. Correct answer is D. It is scalene because it has no equal sides. All right, so you're a side, you're a side, you're a side. They're all different, so it's scalene. Remember, isosceles means you have 2 equal sides. Right means you're 90 degrees. Obtuse means you're bigger than 90 degrees. All right, 37, just have some markings. So I have 2 sides marked equal. So that's isosceles. So I'm going to wipe out this one. And this one, and now is it obtuse or is it right? Well, this angle right here tells me that it's got to be a right isosceles. So let's keep going. Boom, boom. 38, write a statement that indicates the triangles are congruent. So this is more of a matching kind of game. So I just start with the one arc. I always kind of do the angles. L goes with D. So I see L and D. That looks good. L and E. Nope. L and D. That looks good. L and D. That looks good. So we eliminated one answer with L. We should finish it with the next one. So I have a 2 arc is M. 2 arc is E. So M and E got to be in the same position. M, ooh, not E. M, E, looking good. M, F, no good. Correct answer here is B. 39, state if the 2 triangles are congruent. If they are, state how you know. Well, I do see that they share a side in here. So by the reflexive property, I actually have that one too. So now if I just kind of focus on one triangle right here, I'm just going to kind of redraw it to make it a little bit easier to see what's going on. Tick mark, arc. And to me, that looks like we have 2 sides and the included angle. So this is a good old side angle side. Things are looking really good. All right. Let's keep going. Number 40 and 41. So number 40 says, what additional information is needed to get angle, angle, side? So we need to have angle, angle, side. Well, let's look at our picture. Right now, we have a side. So this one's taken care of. We need a couple more angles. Well, I see that we could get this vertical angle here. So that's an angle. Now, I need to get one more angle. And I got to be very careful about which angle I get, because remember, there's also angle, side, angle out there. Which angle, side, angle is when you have two angles and the side trapped in between. So I don't want the side trapped in between. So I don't want F and N because the side will be trapped in between. What I do want is I want D and I want L. Correct answer there is B. All right, number 41. I see these two sides, so that means these two angles are equal because this is an isosceles triangle. Whenever you have an isosceles, you have two equal sides and you have two equal angles. So one's pretty easy. X is 69. Moving forward, 42 and 43. Similar ideas here, except for this triangle is kind of sideways. So if these are the two sides, remember they kind of point to the two angles. So these two are the two angles that are equal. So 50 is the different one. It's called the vertex angle. So this up here is the vertex, where these dudes down here are base angles. So let me do 180, subtract the vertex angle. That leaves 130. I now need to split that up evenly, and that should give me 65 for both pieces. So x equals 65 for that one. 43, I have an equilateral triangle. Three equal angles means three equal sides. So this side needs to equal this side. So 2x minus 6 needs to equal 6, which means 2x needs to equal 12. Divide, divide, and we get x equals 6. All right. 44 and 45. So 44 says that the measure of angle 2 is 8x minus 7. So this expression can replace that measure of angle 2 down there. So let's just go ahead and let's just do that first. It's kind of annoying me that it's there. So I do see I have two equal angles. And I have a 50 degrees chilling here at the top. And now I'm going to write an 8x minus 7 down here. Well, let's just kind of think this through. This is a similar number to what we did before. If I do 180 minus the 50 at the top, there's 130 degrees left in the triangle. But because it's isosceles, this angle needs to equal that angle. So I need to divide it by 2. And that'll give me you need to be 65 and you need to be 65. So there's our equation. 65 degrees needs to equal 8x minus 7. So I'm going to add 7 to both sides, and I get 72. Divide both sides by 8, and I get x equals 9. Boy, there's a lot of x equals 9s on this test. All right, now we're moving into the transformations. All right, number 45. Let's get after this. So find the coordinates of vertices after each transformation. So a translation, remember that's a slide. So we need to slide every point 4 to the left and 2 up. Just looking at my answers, like I'm kind of peeking, pick a point like D. I see different D's all over the place. So that tells me I don't need to move all the points. I'm going to pick one point and just move it. So I'm going to go from D, I'm going to go 4 to the left. 1, 2, 3, 4. And then I'm going to go 2 up. 1, 2. So it looks like my new D prime is chilling right there at 0, 0. So I think I can just finish her up and do that. Now if I did all the other points and I went 4 left, 2 up, that would be the new C. And then if I did E, 4 left and 2 up, it looks like that would be the new one. So You could go through and do them all, but it's kind of unnecessary. All right, next problem. Number 46. Same idea, but now it's just like, hey, can you do it in symbols and not just words? So quick little refresher. If it's x minus, you're going to move to the left. If it's x plus, you're going to move to the right. You might want to put this on your cheat sheet. Y minus, we're going down. And y plus, we're going up. And if it's just an x or a y, then don't move that one at all. Don't go left or right. So looking at this one, let's try it again to just pick one point. I'm going to pick the point F. And I need to move 3 left. So 1, 2, 3. And then 1 down right there. So that's the new F prime. And that point is chilling at 0, 1. So 0, 1, bam, right there. So not too bad, pretty quick. Let's check out 47. 47, I got to shrink because my answers are going out of my screen. So this is just kind of the same thing, just going backwards. I give you the pictures. Now be careful on this one that you see where the start and the finish is. Because, you know, the question is, did we go down and right or did we go up and left? I got to find a letter like I and then I prime to realize the direction. So the direction went left 3. So I need to go left 3. And then from there we went up 5. So in symbols, left 3 up 5 is x minus 3, y plus 5, which looks like C is the right answer. Oh, snap. All right. Nobody saw that, so don't worry about it. A few snickers from the crowd. Write a rule to describe the transformation. So I don't think this was a slide. This to me looks like a flip, a reflection. And I got to figure out where did it reflect from. And I can just kind of see it. Like I'm pretty sure the reflection is right here. But just to be sure, something you can do is you can connect a point to his new image and connect those two with a line. And then create the perpendicular bisector. The perpendicular bisector should be the fold line. And if I did that, you know, for P, that red line there is at 90 degrees. It is right in the middle. So now the key here, you got to be kind of careful because I could see good kids having the wrong answer. But this horizontal line here, this is y equals 1. I could see some people accidentally picking C, x equals 1. But just the key thing to remember is, like x equals a number is going to be a vertical line. And y equals some number, some constant, it's going to be a horizontal line. So be careful that you make the right choice there. 49. We need to make a reflection across x equals -1. So let's use that fact I just told you. X are the vertical lines. So x equals -1 means every point needs to be flipped across this line right here. Again, do I really need to flip all of them? Probably not. I mean, look at R. You have 4 different R's. So right there tells me just flip one point, you're good to go. So if I take this R and I bounce it over that red line, I'm 2 away. I got to go 2 away. Here's the new and improved R. So where does that dude live? It's at, here's 0, 0. I got -1, -2, -3, and then down 2. So here is the new and improved R, which is right here. Now I could do it for all the points, but why? No need to. Next. 50. These ones are kind of rough. This is where you're definitely going to want to have it up on the board, your cheat sheet. Rotation 180 degrees about the origin. Well, the rule for a 180 degree or a -180 for that matter, they're the exact same, says take x, y, and then you need to leave them in the same position, but change the sign of x and change the sign of y. That does not mean it's going to be negative. It means it's going to have the opposite signs. So be careful you don't jack that up somehow. All right, so let's do this. Let's rotate A. I mean, heck, you probably don't need the rule. To go A 180 degrees around the circle, it's going to put it right there. So A prime is at -1, -1. That might be enough to cheat this problem. Oh man, didn't even really have to apply the rule. But if you want to apply the rule, I'm just going to break it down for you. So how we were doing this on Khan Academy is you were writing down the points. You're saying, hey, A is 1, 1. B, you were at 1, 2, 3, 4, up 4. Cha-ching. C, you were at 5, 2. And now we take the XY rule and we make it be opposite X, opposite Y. So opposite X, opposite Y. Opposite X, opposite Y. Opposite X, opposite Y. And looking through, that matches up with this one. But that's a lot of work. You don't need to do all that. That's why some kids finish the test so fast, because they realize they don't have to do all the work to find the right answer. It's good for the SAT. All right, rotation 90 degrees clockwise. So 90 degrees clockwise means you're going this way, which is really negative rotation. All right, so that's really a -90. So you need to use the proper rule. The rule is for 270 and -90. It's XY needs to move to Y negative X. Now, even if you didn't have the rules, you could probably kind of figure this thing out with just 1 point, but let's just use a rule. Let's just do it the way we're supposed to. I'll take a point. I'm going to just take 1 point T. I'm going to take point T. He's chilling right now at 3, -1. Minding his own business. Somebody rotates him around the clock in the negative direction, 90 degrees. So the rule says the Y has got to jump to the front. So my Y value jumped to the front. And then my X value jumps to the back and changes sign. So the new T, T prime, is chilling at -1, -3. And let's just find the answer where the new T is at -1, -3. It looks like this one. Now you do want to check them all just to make sure there's not another T that did that. And there wasn't. It's looking like most of these answers, there's only one good answer. All right, last but not least, David's waiting on me patiently to get this video uploaded. So, write a rule to say what happened. Well, what happened was on this one, I don't think I can just slide it because the U somehow flipped to the other side. And I don't think I can just flip it. So it looks like a rotation had to have taken place. So I'm going to say I know I didn't just slide it. This would say don't move left or right and go down 3. That couldn't have happened. Reflection across the x-axis couldn't happen. That would actually look like this if I reflected it across the x-axis. So that can't happen. So that wipes out this dude. That wipes out that dude. Rotation, so did we go 180 or did we go 90? Well, here's U, and here's the origin, and here's the other U. Well, that's a straight line. That's a straight angle. So I went halfway around the clock. So that's a rotation of $1.80. If you really wanted to be hardcore, you could write down point U as 2, 1, and write down the new point at -1, -2, and then look through all the transformations to see which one it was. You know, so you got all these XYs here that either do this, it does this, or it does this, and you just got to see which one it was. So it looks like they both trade places and they both change signs. Oh wait, crap, I did something wrong. I was like, man, it's none of them. I wrote that down wrong. It's 1, 2. So it looks like they stayed in the same spot, but they changed opposites. So that's here, which was the 180. But visually, I could just see it. I didn't really need the rule. Hopefully you went through. Like I said, make sure to, like I said in the beginning of the video, if I were you, I would go down to the very bottom. I would start here. I would check all my answers. I'd pause the video, check my answers. Any ones I missed, then you can kind of speed up going through. Good luck. See you.